Hello, my dear students. In the last class, I explained what is elastic constants, lateral strain, and linear strain, and solved one example also. So today we will see one more example. A steel bar of a metal bar of 50 mm by 50 mm in section is subjected to an axial compressive load of 100 kilonewton. If the contraction of a 200 mm gauge length was found to be 0.5 mm and the increase in thickness 0.04 mm, find the values of Young's modulus and Poisson's ratio for the bar material. Okay, here what you have to calculate, you have to find the values of Young's modulus, that is nothing but E, and Poisson's ratio, that is mu or 1 by m. Okay, what are the data given here? This is cross section, so B into thickness, okay, breadth into thickness, so width is equal to 50 mm and thickness is equal to 50 mm. Then axial compressive load of 500 kilonewton, that is P, 500 into 10 raised to 3 newton. If the contraction of a 200 mm gauge length was found to be 0.5 mm, means if the contraction, that is nothing but change in the length, deformation, that is found to be 0.5 mm. Okay, so delta L is 0.5 mm and this is the gauge length, means original length. So L is equal to 200 mm. Okay, you read the sentence properly, then you write what are the given values. Okay, if the contraction of a 200 mm gauge length was found to be 0.5 mm, means delta L is 0.5 and L is 200 mm. Okay, next the increase in thickness, that is nothing but change in the thickness. Okay, it is increase, so there is a change in the thickness, so change in the thickness is equal to 0.04 mm. Okay, how to start with? We know the formula for the deformation, right? What is deformation? Deformation is equal to delta L is equal to PL into EE, correct? So delta L is equal to P into L divided by A into E, correct? So here what is we know delta L, that is given here, this is 0.5, and P we know that is 500 and L we know that is 200 and A also we know that is 50 into 50 and E is the unknown value. Only this is unknown, correct? This E is the unknown value. So substitute the values. Delta L is 0.5 mm and P is 500 into 10 raised to 3, this one, and L is given length, that is 200 mm divided by A is 50 into 50 and E is the unknown. Okay, when you simplify this, you get E is equal to 80 into 10 raised to 3 Newton per millimeter square. Why this is Newton per millimeter square? It is Young's modulus. Young's modulus is stress divided by strain and this is in Newton. P is in Newton and area is in mm. Correct. So that's why this is in Newton per millimeter square. That is equal to, you can write 80 GPa also. Okay, now first thing is done, that is Young's modulus you calculated. Now we will see how to calculate Poisson's ratio. What is Poisson's ratio? That is nothing 1 by m, or this is also equal to mu. Okay, value of the Poisson's ratio of the material. What is that? Mu is equal to, it is the ratio of lateral strain to the longitudinal strain or linear strain. Okay, so now first we have to calculate what is lateral strain and then we have to see what is linear strain or longitudinal strain. What is lateral strain? Lateral strain is either it is with respect to thickness or with respect to depth or or with respect to width, correct? What is longitudinal strain? That is with respect to the length. That is nothing but linear strain, delta L. Okay, so first we will see delta B. Can we calculate delta B? No, because we don't have delta B value, right? So lateral the width we cannot find. Mm, but lateral thickness, how you can find? We have increase in the thickness, that is nothing but delta T. Okay, we have T also, that is 50. So we can find lateral strain with respect to thickness. Okay, so fine. How that? Lateral strain is equal to change in the thickness divided by original thickness. Okay, this lateral strain may also be equal to change in the breadth divided by B, but we don't have change in the breadth value. That's why what is the given value? Thickness is given. That's why I'm using delta T divided by T, that is equal to lateral strain. What is delta T? It is given here, that is 0.04. Substitute divided by T, original thickness, that is 50, right? Substitute, you get this is the lateral strain. Over. Next, we'll find what is linear strain. How you can calculate linear strain? Linear strain is nothing but it is the change in the length divided by original length. It is the deformation. It happens along the line of the axis of the force. Correct? So, linear strain is equal to change in the length divided by original length. Change in the length, it is given here, that is 0.5 divided by original length. Original length is 200 mm. Correct? Substitute. You get linear strain is equal to, or longitudinal strain is equal to 0.0025. Now you know what is lateral strain, what is linear strain. How you can calculate mu? Mu is equal to lateral strain divided by longitudinal strain. Substitute that. Mu is equal to now 0.0008 divided by 0.0025. You get the value mu is equal to 0.32. This is also equal to 1 by m. Any value you can consider, symbol, either 1 by m or mu. So that is equal to Poisson's ratio. I hope all of you understood now how to calculate the change in the thickness, or change in the width, or change in the length, or if it is asked to find Young's modulus or Poisson's ratio. Okay, only you should know what is longitudinal strain or linear strain and what is lateral strain. So linear strain or longitudinal strain is always it is with respect to the direction along the line of the axis. The force is acting along the line of the axis. Okay, but lateral strain is always opposite to the application of the force. Suppose if the force is applied along the line of the axis, the delta L, that is the linear. Okay, then delta D or delta B or delta T means change in the width, change in the thickness, or change in the diameter. That all comes under lateral strain. Once if you know lateral strain and linear strain, you can calculate Poisson's ratio. What is Poisson's ratio? Poisson's ratio is equal to lateral strain divided by linear strain. So in this way you can calculate the elastic constants. Okay, next class we will see the other type of the elastic constant. I hope all of you understood. Thank you.